everyone, today we are going to learn about how to actually write piecewise functions when given a graph. So before we get started, what I would like you to please do is complete the warm-up where I want you to solve each inequality and I want you to graph the solutions on a number line. The two inequalities I would like you to graph or to solve and graph are 2x plus 5 is less than or equal to 17 and -1 is less than 7 minus x, which is less than or equal to 3. Please pause the video, complete each part of the warm-up, and then when you have an answer, please restart the video and we'll see how well you did. Okay, for the very first problem, what we want to do is we want to get x alone on the left-hand side. So the first thing you need to do is subtract 5 on both sides. And by doing that, you end up with 2x is less than or equal to 12. From here, we need to divide both sides by 2 to get x alone. And when you do that, you find that x is less than or equal to 6. So if we were to graph this on a number line, we would simply put 6 in the center. And because we have an equal to symbol, 6 is going to be a part of our solution set. 6 would make this statement true. So I'm going to shade all of the values of x that are less than or equal to 6, which indicate that I'm going to select numbers that are, or shade numbers that are to the left of 6. And that is your first answer. For letter B, we want to get x alone in the middle. So the first thing I'm going to do is I'm going to subtract 7 on both sides. Not just both sides, not only in the middle, but all sides. And by doing that, we end up with -8 is less than -x, which is less than or equal to -4. Unfortunately, at this step, x is still not alone, so I'm going to rewrite the problem up here. So I have -8 is less than -x, which is less than or equal to -4. And x has a negative next door to it. So what I need to do is I need to divide in the middle as well as all sides by -1. And I end up with 8 is less than, I divided everything by a -1. So that means that my inequality is going to change. And I have x is actually, 8 is actually greater than x, which is greater than or equal to +4. Please be careful. Now, whenever we graph these numbers on a number line or graph a solution on a number line, we always go in numerical order. And unfortunately, 8 and 4 are not in numerical order from smallest to largest. So we're going to rewrite this so that 4 is less than or equal to x, which is less than 8. And to graph this on a number line, I'm going to put 4 down here and 8 right here. 4 is going to have a closed circle because it has an equal to symbol. And 8 is going to have an open circle because it does not have an equal to symbol. It's just simply less than. And I'm going to connect a line between these 2 points to indicate that our solution for x is going to be between these 2 numbers. What we just drew here is a segment. And in letter A, we drew a ray. And understanding that number lines can produce rays and segments is going to be a very important piece whenever we are writing equations for piecewise functions. So our learning objectives for today are for you to be able to say, I can define, write, and graph a step function as a piecewise function. And I can write a piecewise function for a graph. So the first thing that we're going to talk about is a step function and what a step function actually looks like. Now, a step function is a special type of piecewise function. It is a piecewise function that actually resembles a set of stairs, and it is defined by a constant value over each part of its domain. Now, what you see here in example number 1 is an example of a step function, and as you can see, it looks like a set of stairs. Now, each piece is a segment, which a segment is a piece of a line. And also notice that these pieces are flat. They're flat horizontal lines. And if they're horizontal, that indicates that they are Hoy situations. Horizontal lines, 0 is the slope, y equals a number. And that's what constant value means. So a piecewise function that resembles a set of stairs and is defined by a constant value. That means that your equation is going to be y equals simply a number. Y equals a constant value. So when we write a piecewise function, we're going to need to make sure that we identify our domain pieces, and then we're going to need to identify the equation for each piece. And those are our steps. So step number 1 is to identify the domain pieces. So the domain for each piece. So I would recommend that you label each of your pieces with numbers. So I'll label the first piece number 1, the second piece number 2, and the third piece number 3. Let's talk about number 1. Notice that all of these are segments. And segments means that we are going to be writing a compound inequality that looks like a sandwich. So let's look at the domain. I'm going to write all of the values of x at the bottom. So this is 1, 2, 3, and 4, and over here is -1. So our domain piece, well, just looking at our first piece right here, let me make this clear for you. I am just focused on just this first piece. Now, this first piece is touching all values of x, going from 0 to 1. 0 has a closed dot, and 1 has an open dot. So our first piece, or our first domain piece, is going to be 0 is less than or equal to x, which is less than 1. That is our first piece, and I'm going to put a little number 1 right here. The second piece is right here in the middle. I'm going to bring this right on over. And the only values that are being touched looks like it's from 1 to 2. 1 has a closed circle, and 2 has an open circle. So my domain is going to be 1 is less than or equal to x, which is less than 2. And my third piece, if I were to isolate just that side, it looks like it's all of the values in between 2 and 3, where 2 has a closed circle and 3 has an open circle. So my piece is going to be 2 is less than or equal to x, which is less than 3. Awesome. So those are my domain pieces. Step number 2 is I need to write an equation for each piece. So I'm going to write an equation, that's what I'm going to write down, for each piece. Now remember, these are hoist situations, so we need to figure out what y is equal to. So I'm not interested in x anymore. I'm just interested in my y values. What values of y are being touched? And this time I'm going to insert the numbers. So I have a 1, a 2, and a 3, and up here is 4. So looking at my first piece, what value is being touched? Well, right here, it's at 1. So I'm going to write y equals 1. For number 2, my flat line is at 2. Y equals 2. This is a piece of the line, y equals 2. And finally, our third piece, this is a part of the line, y equals 3. So now that I have all of my domain pieces and all of my equation pieces, I now can do step number 3, which is to actually write the piecewise function. So remember that to write a piecewise function, you'll either write y equals or f of x equals. It doesn't really matter. I'm going to write f of x equals because it's in function notation. And I'm going to write a really large bracket. You must have the bracket included because this indicates that f of x is equal to either the first, second, or third option. So the first option is the number 1. Don't write the y equals as a part of it, just what the equation is. And in this case, it's just the number 1. And that happens if, and you have to use the word if because this is conditional. if 0 is less than x, which is less than 1. For our next piece, I'm going to write the number 2. F of x is equal to 2, and that happens if 1 is less than or equal to x, which is less than 2. And our third piece is 3. F of x is equal to 3, and that happens if 2 is less than or equal to x, which is less than 3. And that is how you write a piecewise function for a step function graph. Let's go ahead and look at number 2. For problem number 2, we have 2 rays, and I know that it's kind of challenging to see, but technically at the end right here, these are arrows. So if it helps you to draw in the arrows just to see that these are rays, that might be a good thing. We're going to follow the same steps as what we see up here. The first thing we're going to do is identify our domain pieces. Step number 2 is we're going to write an equation for each piece, and step number 3 is we're going to write the piecewise function. So I'm going to follow these steps over and over again. It's always helpful to label your pieces. I'm going to label this first piece number 1, and over here I'm going to label this piece number 2. So step number 1 is we want to identify the domain. So I'm going to call it step number 1, domain. And for my first piece, I need to really just focus on it. It's a ray. And this ray, sometimes it's helpful if you write in your numbers. So this is the number 1, and this is the number 2, and the number 3. And it looks like it's starting at the number 3, but it has an open circle right here, which means that it is going to be either a less than or a greater than. And because all of the values of x that are being touched are smaller than 3, our first domain piece is going to be x is less than 3. Cool. For the second equation, let's go ahead and look at this domain. It has a closed circle, and all of the values of x that are greater than are being touched. And so since it's starting at the number 3, my domain piece is going to be x is greater than or equal to 3. Cool. I have my domain identified. Step number 2, we need to write an equation. So this is our equation piece. And these are pieces of lines. So they're going to be written in the form of y equals mx plus b. Let's talk about the first piece. So the first piece, let's see if we can identify the slope. So I'm just going to pick a couple of points, and it appears as if the slope is going down 1 to the right 1. So that means that my slope is equal to -1. My b value is going to be the number 4 because it's crossing 4. So my equation is going to be y equals -x plus 4. Cool. Let's go ahead and identify the equation of the second piece. In this problem, clearly we can see that we can identify what the slope is. So I'm going to put a point right here. This is where it crosses, and I'm going to zoom in just so that you guys can see. It looks like the ordered pair 6, 6 is being crossed by a corner. So it looks like I'm going to be rising 2 and running forward 3. So this is 2/3. So it appears as if my slope is 2/3. My b value, well, I'm going to have to extend using my slope. So that means I'm going to do the reverse of the slope, and I'm going to go down 2 and back 3. And when I do that, going down 2 and back 3, it would appear that the b value would be 2. So b is equal to 2. Because remember, this is a piece of a line, and we're just trying to figure out what the equation of that line would be. So my equation is 2/3 x plus 2. Cool. Now we're on step number 3, where we actually write our piecewise. So writing our piecewise function, this is going to look like, you can write f of x or y equals, whatever you want to do is fine. I'm going to write y equals just to show it really doesn't matter. Y equals, and we're going to write our piece, our equation. So this is -x plus 4, and that happens if I'm going to write down my domain for the first piece, which is x is less than 3. Next, I'm going to write down the second equation, which is 2/3 x plus 2, and that happens if I'm going to write down my second domain piece, and that is x is greater than or equal to 3. And you're done. Your first piece and second piece. Now let's say that you made this a piece that I called 2, the number 1, and the piece that I called 1, the number 2. Would your answer be correct? The answer is yes. As long as your domain pieces match with the correct equation, it doesn't matter which one comes first. What's important is that the equation matches with the domain, and you have the word if, and you have a brace, and the structure is still the same. That's what I'm looking for. All right, let's go ahead and look at example number 3. For example number 3, we have a lot of segments. And in this case, we have 3 different pieces. So I'm going to label them 1, 2, and 3. And we're going to follow the same steps. First, we're going to identify the domain of each piece. So for the first piece, it might be helpful if you have something to cover. So for my first piece, it appears, and I'm going to insert my numbers because I'm a visual person, so I need to just see this. I'm going to insert my numbers. It appears as if it's starting at 3 and ending at 6. So it's starting at -6 and ending at 3. -6 has a closed circle, and -3 has an open circle. So my first domain piece is -6 is less than or equal to x, which is less than -3. For the next piece, it looks like it's starting at -3 and ending at 4. So my next domain piece is going to be -3 is less than or equal to x, which is less than 4. 3 has a closed circle and 4 has an open circle. For the third piece, just looking at the domain, just looking at the x values, it appears to be starting at the number 4 with a closed circle, and it ends at the number 8 with an open circle. So my domain piece is going to be 4 is less than or equal to x, which is less than 8. Cool, I have my domain pieces. Now I'm going to write my equations. So we're going to write the equation for each piece. So I can identify the slope here, and it appears to be 1, rising 1, running 1 to get to each value. So it appears as if my slope is equal to 1, and I need to extend in order to find my b value. So I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1, and it appears as if my b value is the number 7. So y is equal to x plus 7 is my first equation. Step number 2. This is a flat line. It's a flat horizontal line. So it's a y equals a number. This is a Hoy situation. And it appears that y equals, if we were just to look at our y value, it equals the number 2. Cool. And now we are at piece number 3. So let's go ahead and look at what that slope is. Looking at it very closely, it appears as if the slope is going down 2 to the right 1, down 2 to the right 1. So my slope in this case is m equals -2. Now I need to find my b value, and this is where it gets a little bit tricky. If I were to rise 2 and run backwards 1, and rise 2 and run backwards 1, I'm now officially off the graph, which means in order for me to accurately identify what my b value is, I'm going to have to use either point slope form or the b method. So that's what we learned in our first chapter, point slope form and b method in order to find our b value. I know 2 of the ordered pairs on this piece, so you choose. This first ordered pair is located at 4, 6, and this second ordered pair is located at 8, -2. So you select which point you want to work with. I like working with positive numbers, so I'm going to work with 4, 6. And I also like the B method, so I'm going to go with the B method. But if you like point slope, work with point slope. So I'm going to plug all of these values, 4, 6, and m equals -2, into my y equals mx plus b formula. And I'm going to write 6 is equal to -2 times 4 plus b. So I have 6 is equal to -8 plus b. I'm going to add 8 to both sides, and I end up with b is equal to 14. So now that I know that b is equal to 14, I can write my equation as y is equal to -2x plus 14. Cool. I have all of my equations for each piece provided. I have all of my domain pieces up here. And now I'm ready to write my piecewise function. I'm going to call it PWF. And you can write it as f of x equals or y equals. So I'm going to write f of x is equal to, and you just need like a squiggle. And I'm going to write my first piece is x plus 7, and that happens if -6 is less than or equal to x, which is less than -3. My second piece is simply the number 2, and that happens if my domain piece is -3 is less than or equal to x, which is less than 4. And finally, my third piece, the equation is -2x plus 14, and that happens if my domain piece is 4 is less than or equal to x, which is less than 8. And there's your piecewise function. Now, please go ahead and try example number 4 on your own. This is an absolute value equation and very similar to what we just did in our last lesson. You can clearly see that we have 2 rays here. And so I would like you to please go ahead and try writing a piecewise function for this absolute value function on your own. When you have an answer, please restart the video and we'll see how well you did. All right, so the first thing you want to do is identify what your vertex is or what your domain is. And our vertex in this problem, it appears to be located at -1, 2. So there's our vertex. It's located at -1, 2. And our focus is always on the vertex x. So -1 is going to be very important in this problem, and it helps us to identify our domain. So I'm going to label each piece number 1 and number 2. If you labeled your pieces differently, that's okay. So here is piece number 1. For piece number 1, my domain is going to be all values of x that are less than -1. So here's -2 and -3, and it touches all of those values to the left. Now, I said if you can interchange your equal to as long as one of them is equal to and the other one is not, you're good. So I'm going to make this simply, my first piece is x is less than -1, just to make sure that I establish that one is an equal to and the other one is not. Otherwise, you'll have overlap, and it's technically not considered a function anymore. So you need one to have an open circle and the other to have a closed circle. The second domain piece is going to be all values of x greater than or equal to -1. So this is a 1, a 2, and a 3, and all of the values of x that are bigger than -1 are being touched by this side of the ray. So that is x is greater than or equal to -1. Step number 2, we need to come up with our equations. So for my first equation, I need to identify what the slope is. So the slope appears to be going down 1 to the right 1, down 1 to the right 1. So -1 is my slope. My b value, well, let me just continue the slope, and it appears to be about right here as a part of this line. My b value would be located at 1. So my equation is going to be y equals -x plus 1. My second equation, let's identify the slope. It appears to be rising 1 and running 1, so I'm going to write m equals 1. And my b value, it's crossing 1, 2, 3, where y is equal to 3. So my equation is y equals x plus 3. Now that I have my domain pieces and the equations, I'm ready to write my piecewise function. So my piecewise function is going to be, where you can write y equals or f of x, it does not matter. And just make sure you have a squiggle brace. And my first equation is going to be negative x plus 1, and that happens if x is less than negative 1. And my second piece is x plus 3, and that happens if x is greater than or equal to negative 1. And there is your piecewise function. As well as the end of this lesson. If you are struggling with piecewise functions, or you have a question based on this lesson, or you need help in any way, please feel free to talk to me during class, after class, or feel free to email me. I hope you have a wonderful day, and I will see you soon.